medium ISP, fully analog Titus Appleyard ACES clock. This project was powered by a 3-volt motor that was geared down from 1000 RPM to 5 RPM. This was then controlled with a potentiometer so that it could be set at the right speed. The next part of this build was designing the gears. For this, the gears were designed using the scripts and add-ons tools in Fusion 360, which can be a powerful and efficient way to create complex gear geometries. To start designing using the scripts, users can install it through the Fusion 360 add-on menu. Once installed, the user can access the gear generator tool by clicking the scripts and add-ins button on the toolbar and selecting the gear generator from the list. Users can choose between a C and a Python version. With the gear generator tool open, users can customize parameters such as gear module, number of teeth, pressure angle, and more. The scripts will automatically generate a profile based on these parameters, which can be used to create the final gear geometry. The next part of the design was the clock body. It was initially designed to have a blank face, but was changed later to have a clear acrylic face partway through the design process. This was created in Adobe Illustrator and cut at the Maker Bean Cafe. Laser cut acrylic uses a high-powered laser beam to precisely and accurately melt and vaporize or burn away the material. Additionally, laser-cut acrylic products create minimal waste. The clock design and dimensions were measured and cut for this build, and then Titus Appleyard was engraved on the face. The final part of this build was figuring out the gearing for the clock. The number of teeth on the gears determines the gear ratio, which measures the relationship between the rotation speed of the input and output shaft. To calculate the gear ratio, you count the number of teeth on the output gear and divide that by the number on the input gear. For instance, if the output gear has 40 teeth and the input gear has 20 teeth, the gear ratio is 2 to 1, or 40 divided by 20. The gear ratio determines the gearbox output speed and torque. A higher gear ratio provides higher torque, but lower output speed. In contrast, a lower gear ratio results in higher output speed, but lower torque. For this build, two 20-tooth gears and two 5x75 tooth gears were used.